All right, again, we're going to use the product rule on this particular problem right here. So, what will this start off as being? Times 2x. No, just times 2, right? Okay. Plus. Okay. Now, do you see that we have some common factors in here? So let's factor out what we can factor out. Got a 2, an x, and a d to the 2x too, right? So what are we left with after we do that? Plus 1. X plus 1. Yeah, you can't forget, if you factor out a binomial, you need a binomial there in the end. So that's what we get as our answer. At 2x times e to the 2x times the quantity of x plus 1. Are we good with that?
Yes.
All right. Now, let's go a little bit further. And let's look at how we can figure out what the derivative of the natural log of x is. We want to determine what is the derivative of the natural log of x. All right. Well, in order to do this, let's just write down this simple fact. From past math classes, what do we know about e to the natural log of x? It's not 1, it's x. It's x. E to the natural log of any value is that value. All right. Now, let's take the derivative of that. Okay? So, taking the derivative of e to the natural log of x, that's going to be the derivative of, let me start, yeah, it's going to be e to the natural log of x times the derivative of the exponent, right? Which we don't know. So I'm going to write the derivative of the exponent as the derivative of the natural log of x. Do y'all follow what I did? This is a little bit different from what I've done in any proof we've done up to this point.
I don't know.
Huh?
Oh, okay.
Yeah. I rewrote my e to the natural log of x, and then I said, okay, we've got to take the derivative of the natural log of x from here. So it's e to the natural log of x times the derivative. Now, what's the derivative of x?
1.
It's 1, right? So e to the natural log of x times the derivative of the natural log of x should equal to 1. Now, remember, this is what we're trying to solve for. We're trying to solve for what is the derivative with respect to x of the natural log of x. Well, what do you think we would want to do here?
What was the question?
Well, we're wanting to solve for this. This is what we're looking for. This is what we have.
Set it equal.
Not quite. What were you saying? Can't do that quite yet. Can't do that quite yet because we don't really know how to do antiderivatives of natural logs yet. Good question. Good suggestion, though.
I understand what we're trying to do.
Well, we want to solve for this.
Solve what?
But how did that E, L, and X come in?
Oh.
This?
Yeah,
All right.
why can you just put that in there?
We didn't just put that in. Remember, what I started out doing here is I took the derivative of this entire equation. And the derivative of e to the natural log of x would be e to the natural log of x times the derivative of the exponent. It's what we just got finished doing. Remember, if we had e to the x squared, its derivative was e to the x squared times the derivative of the exponent. So because I don't know what the derivative of the exponent is, I just had to write it out like that.
Isn't there a rule that says you can, like, if the bases are the same or something, you can set make an equation out of the.
Let me go with this real quick. If we have 2 times x equals 1, and I told you to solve for x, you would divide by 2, right? Very good. All right. So remember, this is what we want to know. Well, it's right here, so let's divide both sides by this. Are you with me? Okay. So we get the derivative of the natural log of x is equal to 1 over e to the natural log of x. So have I solved what I want to solve now?
Now you
Just don't know, I mean, I was wanting to know what the derivative of the natural log of x is. Okay. But there is actually one more step I can do here. I can actually simplify this. It'd be 1 over x, right? So the derivative of the natural log of x is 1 over x. Are you good with that? All right.
So, if this problem
No. Now you know it. What we just did, that's a great question. Kristen just said, if I gave you this problem on the test to find the derivative of the natural log of x, would we have to go through all that? No, I just proved it. What we now know is that the derivative of the natural log of x is 1 over x. And it's going to work every time. We don't have to reprove it every time we solve the problem. Okay? So it's like a formula, yeah. Now, I want to tie this in with what we talked about yesterday. Remember yesterday we came up with this situation right here. What happens if I want to know the antiderivative of 1 over x dx? Alright, so what function has a derivative that's 1 over x? The natural log of x. But I'm going to be careful in doing this. I'm going to write this as 1 over... No, I'm wrong. I'm going to say the natural log of x plus c. But there's one little detail that we have to take into consideration. This value right here can be positive or negative. X right here can be positive or negative. When we put it into a logarithm, we can't take the log of a negative number. That was one of the things you learned in logarithms. You can't take the log of a negative number. And nowhere in here did I say, hey, this has to be positive or this has to be negative, or it can't be 0, of course. But I never stipulated what this could be or could not be. So what I have to do is to ensure that I have a positive number there, I've got to take the absolute value. So the antiderivative of 1 over x isn't just the natural log of x plus c, but it's the natural log of the absolute value of x plus c.